Here's an interesting problem. Integral from 0 to pi over 2 dx over square root of sine x. This is an improper integral because as x approaches 0, the lower limits, we're going to be dividing by 0. That's why it makes it improper. Okay? How do we determine the convergence or divergence of this integral? Well, if we try to evaluate this indefinite integral, dx over square root of sine x, even I don't know how to do it. You might be able to do it with some advanced techniques, but at least all the techniques you learn in a typical Calc 2 or just in general single variable calculus class, you won't know how to do this. Okay? So we got to use a comparison test. Now, the next challenge is to determine what to compare this integral to. And if you got stuck and you asked ChatGPT to help you out, its first answer that it spits out is totally incorrect. Let's go over why actually. And this is important, in my opinion, to realize this mistake because, of course, for studying purposes, but this is important even for, I'm assuming you learned this before you learn about infinite series. When you do comparison tests for infinite series, you use the exact same concepts. You got to get this down. For a comparison test to work, you have to, there's one or two options. If you know that something converges and your thing is even smaller than that other thing, then for sure your thing converges as well. Something smaller than something that converges must converge. That makes logical sense, hopefully, right? Similarly, you can also conclude divergence. If something you know diverges and your thing is even bigger than that something that diverges, then for sure your thing will diverge as well. That makes sense also, hopefully. Okay? That's how the comparison test works. Either you compare with something bigger and your thing is even smaller, or something bigger that converges and your thing is even smaller than that bigger thing, so your thing must converge. Or you compare with something smaller that diverges, your thing's bigger, your thing will diverge as well. You can't use something bigger. How should I say this? Let's just go through the example. If what I'm saying doesn't make any sense right now. Okay. This is what ChatGPT says. Recall sine x is approximately equal to x for small x. If you ever took a physics class, you might have learned this as the small angle approximation. For very small values of x, sine of x is approximately equal to x, or even tangent x is approximately equal to x. And you learn this in physics because when you learn like diffraction and all that stuff, some nice equations happen if you make this approximation. Okay. Therefore, 1 over square root sine x is approximately equal to 1 over square root x for small x. Okay. We're just using that approximation. Okay, so now ChatGPT says evaluate this improper integral from 0 to pi over 2, 1 over square root x dx. You find that it converges. And therefore, since you approximate the integral, our original guy, as 1 over square root x, your thing converges as well. This doesn't use the comparison test properly. Let's look at how these two curves look. 1 over square root sine x, 1 over square root x. Okay, so I have it on Desmos. Let's open it. So this curve is 1 over square root sine x. By the way, I'm only looking at between 0 and about 1.5 because pi over 2 is around 1.5, okay? So this is 1 over square root sine x on screen right now, and then let me plot 1 over square root x. Okay, so ChatGPT concluded that the improper integral from 0 to pi over 2 is somewhere over here. The pi over 2 somewhere over here. We integrate all the way to 0. So that's what's improper. You can see it's infinitely growing. For the improper integral of 1 over square root x, it converges. But look at our actual function that we want, 1 over square root sine x. It's actually bigger. So there's a chance that this will actually diverge because it's bigger. You cannot use the comparison test to say that because this guy, which is smaller, converges, then this thing that's bigger also converges as well. Not always the case. It's bigger, so there's a chance for it to diverge because you're summing up more things. Okay? This is why ChatGPT is not correct to say what it did, to make the comparison like it did. actually, probably some person posted their answer online somewhere, and ChatGPT probably just took it. So whoever did it did not do it properly. Okay. So in order to determine the convergence of 1 over square root sine x, back to this guy, we got to find something that's bigger, a little bigger, that also converges. What's an example? So this is how we think about it. Okay, so that's why I said over here. Since sine x is less than or equal to x, then 1 over square root sine x is greater than or equal to 1 over square root of x, as we just saw. Something bigger than this guy could diverge. That's what I said. Okay, so now to pick the comparison, I just knew that sine x is greater than or equal to x over 4. You can be convinced by sketching the curves real quick. Okay, so first of all, we couldn't use this improper integral to compare. But since we know that 1 over square root of x converges, maybe we can do something really similar to this. This is where experience comes into play. So you should, first of all, memorize that 1 over square root x, as you integrate as x goes to 0, that it converges. Okay? So let's pick something very similar. So I know that sine x is greater than or equal to x over 4. You can be convinced by sketching the curves real quick, okay? The square root of sine x, if I square root both sides, is greater than or equal to square root of x over 2. Now I just invert both sides. So 1 over square root of sine x is less than or equal to 2 over square root x. This is very similar, right? Let's even look on the graph again real quick. So this is on screen right now. It's 1 over square root sine x. 2 over square root x is right there. It's bigger, right? Okay. So if this bigger thing converges, then something smaller must converge as well. So we can easily prove that 0 to pi over 2, 2 over square root x dx converges. You can evaluate the limit, or since we found this one up here, we just multiply by 2. Same thing. Okay. Since this converges, this one right here, and our actual function that we want is even smaller, therefore, our original guy converges as well. This is a proper comparison test, not what ChatGPT did. I can't talk right now. So hopefully this is helpful to understand how the comparison tests work. This is really critical to pick the correct functions. You, again, like we did here, if you find something bigger that converges, your thing that's smaller must converge as well. Or if something smaller diverges, your thing that's bigger must diverge as well. Those are the two thoughts that work for comparison tests. Only those two. Okay. Hopefully I hammered the point down with this concrete example as well. Whoops, I don't know what's happening to my screen right now. But anyway, let me change back to here. Okay. As usual, please give this video a like if you found it helpful in any way. And if you're interested in seeing more of these, please hit that subscribe button as well, and you'll get notified when more videos like this post.